let's see basic applications of exponential and logarithmic functions in exams. So in exam type questions, we're looking at the worksheet question number 6. So question number 6, we have given a basic exponential function. A function is defined as 3 to the x, and they're asking us to determine an equation of f to minus 1, which means that we are looking for the equation of the inverse in the form f to minus 1 of x equal to. Okay, most of the time they ask us in a form y equal to, but it can also be in a form f to minus 1 equal to. So what do we know? We are looking at an increasing exponential function with a base equal to 3, which means that its inverse will be a logarithmic function with a base 3 of x. And that's all. That's what you get your mark for. Okay, very simple. F of x exponential function, the inverse or the reflection in the line y equals to x is logarithmic function with the same base. They're asking us now in a question 6.2 to sketch the graphs of f and f to minus 1 on the same set of axes, showing clearly all the intercepts. Okay, so in order to sketch the two functions, let's start with a form 4, basic exponential function 3 to the x. It is a increasing exponential function with the y-intercept equal to 1. As you know, it's very important to label the axes because especially when we're dealing with a function and inverses, we then know exactly which of the two is my function and which one will be its inverse. Okay, so I've got my function f of x with a y-cut clearly shown and labeled with a value of 1, and my inverse, my logarithmic function, is also an increasing function through the x-cut this time equal to 1. That's my function f to minus 1, and I know that they are a reflection in the line of symmetry y equals to x. You do not have to draw this line if you're not asked to, but it just shows you that they are very nice reflections of each other along this line. What you have to do, you have to label your y-cut and show that it's an increasing function for f. You have to label your x-cut and show that it's an increasing function for your logarithmic function or for the inverse. Okay, back to the questions. Question 6.3, the domain of the inverse, that's the values of x for which my function makes sense. So what's the domain? It's x element of 0 to infinity, or we can say x is bigger than 0. It cannot be equal to 0. Why it cannot be equal to 0? Because the y-axis of the line x equal to 0 is now an asymptote of my inverse function. Question 6.4, for which values of x will the multiplication of the two functions be negative? Okay, what does it mean on the graph? Multiplication of two functions negative. It means the one function must be positive, one function must be negative, or we say one function must be above the x-axis while the other one is below at the same time. Looking at our functions, as we are approaching from minus infinity, we only have a one function, so that will not work. At 0, we also have only exponential function that exists, and logarithmic function does not. For any values bigger than 0, my logarithmic function is negative when the exponential is positive. So this condition will hold. So question 6.4, it holds for x element of 0, and it holds all the way to the x-cut of 1. Can I include 1? Yes, I can, because of the sign of inequality is that you can include zeros of your function. What happens for x bigger than 1? Well, both functions, my logarithmic as well as my exponential, are then positive, which means that multiplication will be positive. Question 6.5. 6.5 brings in the transformations, something that is also very important. You were very good with it last year, so I hope that you did not forget. The question is to find out the range of a function h of x, where h of x is now defined as 3 to the power of minus x. Now remember, I don't like powers minus x, so I prefer a third to the x minus 4. Now this isn't a separate question, it's a question within our question 6, which means that it refers to my function 3 to the x. So what happened to my function 3 to the x if it became h of x? Well, firstly, it was reflected, so the x became negative x, so it was reflected in the y-axis. It was reflected in a y-axis. Does the reflection in the y-axis, okay, so look at the y-axis, if you reflect function f in the y-axis, will it affect the domain? No, it won't. Will it affect the range? No, it won't. Okay, it will just go down here, but the domain and range will stay the same. However, furthermore, the function is shifted 4 units down. Okay, now shift down and up. Will it affect the domain? No, the domain will not be affected. Will it affect range? Yes, it will affect range of a function. So now my function goes 4 units down, which means that instead of range being from 0 to plus infinity, now the range will be y bigger than, not bigger than 0 anymore, bigger than 4. Or in the interval notation, y element of 4 to plus infinity. Okay, not 4, but obviously minus 4, I went 4 units down with my function. Okay, let's look at the last question, which was question 6.6. Question 6.6 was to write the equation of a function g of x, and what we knew about g of x, it was an image of f after I translated f 2 units to the right and then reflect about the x-axis. Okay, so first is the translation and then is a reflection. So if I translate 2 units to the right, then my function would become y equals to 3, 2 units to the right, x minus 2. Okay, reflection in the x-axis. What happens? If I reflect in the x-axis, every y becomes minus y, every minus y becomes positive y. So my function will be minus y equals to minus 3 to x minus 2. Sorry, I went too quickly. Minus y is 3 to the power of x minus 2. Therefore, y is minus 3x to minus 2. Agree? What's the value of my base in here? The base of my exponential function in this example is 3, boys. Base is positive. It just has a negative coefficient in front. If you need to play it again, play question 6 again. We are now going to look at question number 7 and 8 in the same video. Question number 7 deals with the function f of x equal to 3 to the power of x. And notice, boys, how often the 3 to the x or 2 to the x comes up in the exams. It's different worksheets, different exams, different provinces, yet the function remains the same, 3 to the x. Again, very basic. Question 1, write the equation of the inverse of f in the form y equals to. So in this example, we've got very easy. Once again, the inverse of exponent will be a logarithmic function with a base 3 of x. That's our answer for question 7.1. Question 7.2 is slightly different. That's why we are looking at this question, and we are asked to sketch two graphs. The graph of f2 minus 1. So they're testing you to know that you understand that the inverse has a symbol f2 minus 1. And then they're asking you to sketch the graph of f2 minus 1 of x minus 2. So what happens if I have x minus 2? Well, we have a shift or a translation of 2 units to the right. My graph moves 2 units to the right. In the previous question, we were asked to write an equation. In this question, we are asked to do interpretation. So sketching the inverse first, the basic one. Remember, once again, we are looking at an increasing logarithmic function with an x cut of 1. Okay, increasing logarithmic function. This is my function f2 minus 1. What must I do with this function? I have now to shift the given function 2 units to the right. So what do I shift first? Boys, I first shift my asymptote. So asymptote was at x equal to 0. Now 2 units to the right, my asymptote will now be at x equals to 2. Asymptote first. Okay, then the function. So the x cut will not be 1, x cut will now be 3, and I have my increasing function that was shifted 2 units to the right. Okay, that's worth 4 marks, seldom asked, but it's a very very important question. It's considered to be a difficult question. If necessary, pause it, think about it. The most important is that you first do the shift 2 units to the right of your asymptotes, that you don't forget with the restrictions later. Application of the shift is question 7.3, where they ask you to use your graph to solve for the inequality log base 3 of x minus 2 is less than 1. Boys, they're testing a few theory things here. Okay, firstly, they're testing that you know that the inverse has a symbol f2 minus 1. Then they're testing that you understand that the inverse of exponential function is in fact a logarithmic function, and that you know what it means if you look at log less than 1. So where is my 1? Let's say I draw my line y equals to 1 on my graph. And then the interpretation of this inequality is that the logarithmic function must be below the line y equals to 1. So if I look on my graph, I have a point of intersection, some x value of k, and here is where my logarithmic function is below that straight line. Where does it go? What's that interval? Well, that interval must be from this k to the left. Okay, how far to the left? Well, it's only to 2. That's why moving that asymptote was so important. So it goes from 2 to k. I cannot include any because asymptote is not included. K is not included because of the sign of inequality. So what I have left is to find k. The easiest is to make a logarithmic equation. So it's equal to 1. You remember, by definition, we need to change the logs into exponents. So base of the exponent to the power of 1 is x minus 2, which means that the point of intersection, the value of k, is 5. So it will go from 2 to 5. Once again, if necessary, pause it, reverse it, and do it again. The last application question from the worksheet, question 8. It looks as a very long question, but we're only looking at applications that involve exponent and logarithmic function. And once again, there is one question which is slightly different that we have to look at to make sure that you cover all the sides and possible options of logarithmic functions before we move into a natural logs. So in question number 8, we have given a function f of x, which is defined as 2 to the x minus 8. So it's a function that is shifted 8 units down. The questions that are applicable to the function, question 8.1 asks us for the asymptote of f of x. So what's the asymptote of f of x? Well, it's a horizontal asymptote, so it's y equals to minus 8. Please remember, it's not just minus 8, it's y equals to minus 8 because we are asked for the equation of the asymptote. 8.2, give the equation of a function h, which is defined as f of x plus 2 plus 8. Two ways of thinking about how this question can be asked. The way it is just plain algebra. So the way they are asking us, we will just say h of x is, and everywhere where we had x, we will replace it with x plus 2. And since my function had minus 8, and I have to add plus 8 to it, that will simplify. So this will be a function h of x. How else can they ask you? They can ask you to describe what happened to the function f of x as it changed to f of x plus 2 plus 8. So what transformation took place? What would be your answer? If f of x changed into f of x plus 2, then I have a shift or a translation of 2 units in which direction? To the left. And 8 units up. Okay, so they can ask you for this description. And 8.3, that's exactly a question that I wanted you to think about it, to look at this. And it's a question that I'm sure very few of you saw last year. Question 8.3 asks us to find the inverse of f, okay, f to minus 1 in the form y equals to. So my function given is 2 to the x minus 8. We never had a shift down when we were looking before at the inverse of exponents. So let's take it slowly. Okay, what is the process of finding the inverse? The process of finding the inverse is nothing else but a reflection in the line y equals to x, meaning y becomes x, x becomes y. So I have 2 to the power of y is equal to x plus 8. how to take the power down? Well, using a definition of a logarithmic function, it will be a log base 2, but instead of x will be x plus 8. Or you just say, let's log both sides. So it's log x plus 8. Just don't be silly, don't distribute it. We will do the laws of logs in the next lesson. Is equal to a log 2 to the y. The only clever thing is you need to think about whether a log with a base 10 is something that helps us here, or maybe there is another log that is by far easier for us to use. And obviously the log with a base 2 is way better, because remember, the base of exponent, you want this to stay the base of the log. So on the left hand side we have, on the left we have log base 2 of x plus 8, and on the right hand side we had log base 2 of 2 to the y. Right, the most important law of logs, the power comes down, so I have on the right hand side y log base 2 of 2 equals to log base 2 of x plus 8. What's the value of log base 2 of 2? Some of you will quickly do it on your calculator, but think about it. If I want to do interpretation of this, the question would be 2 to which power will give me 2? To the power of 1. Okay, so log base a of a is always 1. Okay, like I said, we will do a little bit more of laws of logs just now, which means that the inverse of my function f of x, now remember, f of x was defined as 2 to the x minus 8. Okay, so that was my function f of x. The inverse of this function in the form y equals 2 is log base 2 x plus 8. Just want you to think a little bit about it. If I think about f of x is a function which was shifted 8 units down. Its inverse is a logarithmic function, log base 2 of x, but that's the original function that was shifted 8 units to the left. Okay, a little bit of thinking about it, but that's just a very different question to any question that you looked at last year. If you need to play it again, if you need to look at those questions again, you're more than welcome. You now have to do the exam tab questions on exponents and logs, very similar questions to the questions 4 or 5 that I did. You have to mark your work. And boys, if you need any help from myself or from Mrs. McDonald, please ask us this week, so you sort out all the basic knowledge that you need for the following section. Good luck.